Banu ma'am, shall we start the session or shall we wait for 5 minutes, ma'am? Very good evening to the dignitaries, respected chairman, honorable correspondent, distinguished principal, dynamic vice principal, esteemed chief guest, active participants and colleagues. I am Dr. S. Uma Mageshwari, professor and head of the department and coordinator of this event. I wholeheartedly welcome you all for the faculty development program. Today we have day 2 session 1 now. On behalf of the Abdul Hakim College of Engineering and Technology, I am so much delighted to welcome you all to our 6 days faculty on development program on cutting edge advances in artificial intelligence and data science. We feel greatly honored to have distinguished guests and experts with us today who will guide throughout this academic journey. It gives me immense pleasure to welcome and introduce our today's guest, Dr. M. Srinivasan sir, Professor and Head of the Department of Information Technology in PSV College of Engineering and Technology, Krishnagiri. He received many awards like Best Innovator Educator Award, Promising and Futuristic Award, Best Faculty Advisor Award, etc. He also acted as AICTE ATAL FDP Coordinator, AICTE Idea Lab FDP Coordinator, NCC Caretaker, NAC NBA ISO Nodal Officer, also VBA PI Coordinator. He has published 24 journals. Along with these 24 journals, he has published many conferences also. He is editorial board member and he has published 4 patents. He has been the chief guest of many events, activities in various colleges. He is a jury member in technical symposium. He has delivered guest lecture in various colleges around the world. He has published 2 books and he has attended many faculty development programs and conferences. Now, I humbly invite our chief guest to deliver his speech. Over to you, sir.
Thank you, ma'am. Thank you for a wonderful introduction. Good evening to everyone. Most respected faculty members, research scholars, industry participants, and my dear colleagues. It's give me a great pleasure to welcome you all to this 6 days faculty development program sponsored by the AICT ATAL. I would like to thank all the faculty members who are all joining and share your thoughts, ideas with me and share my expertise with you. So everyone, once again, I welcome to this wonderful forum. Before start my session, I would like to thank the management of C. Abdul Hakim College of Engineering and Technology, Melvisharam, most respected Principal Dr. M. Sasi Kumar and Vice Principal Dr. Muhammad Muzafir Hussain, and ATAL FTP convener Dr. S. Uma Mageshwari, Professor and Head of the Department of IT Department, were all giving the wonderful opportunity to share my expertise in this wonderful forum, especially the topic deep learning mastery, data intensive, generative AI for the educators. So before start my presentation, I would like to uh, say the wonderful quote, uh, teach smarter, not harder, with the leading generative AI assistant for educators. So this quote given by yesterday speaker, Dr. Muhammad Abdul uh, Madin. So all of you note this wonderful quote given by the yesterday speaker, Muhammad Abdul Makir. Uh, I'm also try to teach smarter in the smarter way, not a harder way, with the leading generative AI assistant for the educator. Now I start with my presentation. I hope everyone see my presentation.
Yes, sir.
Thank you. I'm delighted to be here with you today to talk about the subject that is shaping the future of technology and our daily lives, deep learning, and the power of data. In this talk, I will explain why data is considered the major challenges we used to face handling the large data set and what are the strategies we used to follow as a researcher or a engineers we used to overcome the challenges and what are the direction to be taking care to shape up the next decade of the artificial intelligence. Now, let me ask the simple question to all of you. I think this everyone know the importance of the artificial intelligence and deep learning. Just I want to convey my uh, quick questions. How many of you here used to the Google Photos, YouTube, maybe voice assistant like Alexa or Siri? I think almost everyone right now we used the Google Photos, YouTube, maybe voice assistant like Alexa. Well, so did you know that behind all of these application amazing tools, there is not only the advanced mathematics and algorithm is there, but more importantly, there is an uh, big, massive amount of data that is presented. That's why the data nowadays are ruling the world. There is data, massive amount of data. The deep learning is like if you take a simple example, if you want to run any of the engine, we need to put fuel. Without fuel, we can't run any of the engine. So if you take the deep learning is like an engine, the without fuel it cannot be run. But then what is the fuel? And is like in this case the fuel is the data. Without fuel, the engine cannot be run. The deep learning is like an engine. We need to put a fuel that is called as data. In the next 1.5 hours, we used to discuss the following points. So number one, why data is so important for especially for the deep learning. That is introduction about the overview of deep learning and data, and why the data matters, quality, quantity, and diversity, and data lifecycle flow. What challenges we used to face in using the large data set, and how can overcome those challenges with smart strategies. And finally, how this all connected to the future artificially. These are things we are going to discuss for the next 1.5 hours. If you take the deep learning master data intensive, as we know, all of you know, deep learning is a branch of artificial intelligence. Uh, at this core, it is about the teaching machines to learn the pattern from the massive amount of data, just like a human learn from experience. All of you, coming from background of the teaching faculty members, we used to get the experience with the help of the our professors are guiding the research fellowship. So just like a human learn from the experienced based. So that's what the deep learning thrives on, a large scale data to learn from the computer pattern. So this presentation covers the role of data uh, and deep learning related to the challenges and strategies to realize the data effectively. And then the foundation of the deep learning. So already I mentioned the deep learning is the branch of artificial intelligence. You might have heard about the neural networks. So that is also the coming to the picture. They are the backbone of deep learning. We call them neural. Why? Because they called as a neural network or neuron, because they are the inspired by the human brain. So brain, how it's work, all of you know. So the because of the inspired by the human brain, the neural networks, just as our brain has millions of neurons connected in a layer, The neural network also has layers that process the information as a step-by-step process. Now, how is deep learning different from the traditional programming and uh, the traditional computer rules? For example, if you want to detect whether an email is a spam, or you write to put into the rule if the subject contain the lottery or money market is a spam, so then only we used to find whether it is a safe or not safe. So that are things we used to find with the help of the rule based process. But the deep learning, you don't write any rule. Instead of that, you give the computer thousands of examples. Then only that predict whether it is good or not, or the learned rules, or the spam or not, like that. We used to find the computer thousand of the examples. So let me give the some example. Imagine we want to teach with the child, for example, to how to ride a bicycle. If you take the simple example, do you give the book to how to ride a bike, or how to balancing the cycle, or pedaling, or turning? Obviously no. Let me give the practice, real time practice. The child sometimes fall down, or tries again and again, slowly learn uh, to do the activities. So this exactly how deep learning works, by learning from the experience based only, especially in our case from the data only, give the exponential way uh, for the output. The famous example of the shift Google Translate is the early days. It used to rule based translation. Now coming to the why the data is matter. Now that we understand the basics, let us, why does data matter so much in deep learning? There are three big reasons. So already mentioned that without data we can't do anything, we can't predict anything, we can't process anything. So all those things based on the three big reason: quantity, quality, and diversity. If you take the quality, more examples will fit into the system. The better way it learns. If you train any of the AI, artificial intelligence, to recognize the cat with just 10 images, it will fail. Definitely it will fail. But if you train it with 1 million images of cards, the system becomes very accurate. So that's what the quality in the concern. Quantity and diversity, the data must be clean and very corrective data. If you can data set continue the random continues the random pictures of uh, cleaned data, accurate data, prevent the bias and improve the labelty. The third one is a diversity. If you take any of the data set as only the examples, if you take the example, for example, you take a data set as only black heads, or the AI may fail to recognize a white or any other color. So that's why we go for a diversity data source, different contexts or demographics or environmental, to improve the robustness of the adaptability. The life cycle of the data, the processing, their life cycle flow. Let me share the two real world example. For collecting the raw data from sensor or database, or user input or external A. So there are several ways to collect the data and store the data into any of the storage, like a cloud or any of the distributed database. So we should organize the data in a scalable storage system with the help of the cloud or distributed database. We go for a deployment or integrating the training model into the real world application for prediction. We used to give the training. training. That means feeding the process data into deep learning models for the pattern recognition. Now, next come to the collecting the new data on performance metrics and continually refining the model. I'll tell you the simple example. So, for example, if you take facial recognition system, studies that early facial recognition software, what will happen? So, light skin faces may be performed very well. So, dark skin face sometimes it is order to detect and convey the diversity the enough. So, like that, the self-driving cars also the same thing. So cars trains some of the place struggled, or some of the place working very fine. It could be based on the condition or the environment. If you take the Indian roads are very sophisticated, or the ground clearance. So based on that only the car smoothly running from one place to another place. So that kind of real-time example we should take with the help of the uh, data model. This is what the data is very important. The importance of the uh, deep learning, the large data set to give the improve generalization. We know the generalization, the connectivity between the multiple instances, uh, is to improve the generalization and diversity of the enhanced robustness. Just now I mentioned the facial recognition or self-driving cars, or any of the examples. You should give the diversity, enhance the robustness, and then quality often outweighs the quantity. Yes, so already we've discussed in the previous slide itself what is quantity and quality. Usually, we used to explain in the software engineering subject what is quality and quantity. So, if you go to the very big shop like what Murugan Italy shop, they used to sell 3 idli 100 rupees. If you go to the roadside shop, they used to sell 5 idli at 20 rupees. So there must be a difference between these 3 idli in 100 rupees or 4 idli in 20 rupees in the roadside shops. The quality only the difference between the two shops. If you want to get quality, we go to the very uh, uh, sophisticated or very hygienic shop, hygienic hotels. So like that, they used to give some examples in the software engineering itself. Are we build the product right, or we build the right product? So that's what the best example we used to give the quality and quantity in the Roger Pressman, the software engineering book itself. So that's why I want to illustrate this. The data scarcity leads to overfitting. So these are the important things considering the deep learning. And then what are the major challenges we used to face in the data intensive deep learning? The collecting and labeling the cost, uh, privacy and ethical concern, and imbalanced data set, noisy and unstructured data. So not only these are the challenges, the major challenges. So collecting, labeling the cost and privacy, ethical, imbalanced, noisy, unstructured data. These are things very crucial task to do the deep learning process in a data intensive way. So if you go to collecting and labeling the data, the cost definitely it come into the picture, and accuracy come into the picture, and the building of the data set, that is also come into the picture. The gathering and collecting the data is not a simple task, or labeling the data is not a simple task. The working with the massive data set is not easy. So there are several challenges are there. The first, collecting and labeling the cost. Imagine, we just imagine. So building a data set of 1 million medical images. Usually the medical uh, images we cannot get directly from the any of the hospitals. There are so many restrictions are there. You want to build any of the data set from the medical images. Each images need to be labeled by the expert. That means the doctor. The expert doctor maybe give the labeled for each and every image. This expensive, definitely it comes to the expensive one. So this expensive and it takes more consuming time. The best example, the ImageNet, a famous data set that changed the computer vision, took years of work by thousands of people labeling the millions of images. So that is what one of the major challenges for collecting the data and labeling the data. If take the case study, medical AI are labeling thousands of MRI scan, require domain expert or driving cost of $1 million. If you take Indian money, it will take more than the amount. Next biggest challenges is privacy and ethical concern. If you take the privacy and ethics concern, if you take healthcare data or any GDPR data or HIPAA data or CCPA data, that means General Data Protection Regulation, GDPRA, HIPPA, Health Insurance Probability Accountability Act, CCPA, the Central Consumer Protection Authority of India. We used to get all the permission, then only we used to collecting the required data, the healthcare data or financial data or any of the personal conversation. This cannot be shared freely. Definitely, there must be a paid something to get a data because of the privacy concern. You want to AI to be a powerful, but not the cost of violating the people rights. So risk of the data breaches, ethical misuse of AI, surveillance or biased decision making. So all those things we must to consider while getting the data and using the data. In especially in the healthcare, there must be a patient data without anonymously can lead to privacy violations. Like just now I mentioned the HIPAA mandate strict standards are there for protecting the medical record. So like that, the facial recognition also the same thing. The lack of ethical oversight has raised concern about the bias and surveillance. Another one is biggest challenge, imbalanced data set. What is that imbalanced data means? If some categories may be dominant while others are underrepresented, or models trained on imbalanced data set after overfit or majority classes. That means you just classify majority classes and minority classes. If you get the majority classes, uh, after most the critical thing, for example, the fraud detection or rare disease or misclassified or ignored may be happen. Take a fraud detection as an example. For every one fraudulent transaction, there might be a million of normal ones. The system may learn to always predict normal one, and still 99 points of 9 accurate, but unless in practice in the fraudulent transaction may represent less than 1% of the data. The model could achieve 99% accuracy, be always predicting not product. But the thing is the minority of the class. So that's what I want to mentioning in the medical imaging or rare disease may have very few label. This is the simple example. If you take any rare diseases, if you collect only this few amount of sample only, with a few amount of samples we cannot predict anything for further disease recovery processing. So that's why I'm mentioning the leading to biased diagnosed label. Another one is the biggest challenges, noisy and unstructured data. So in this noisy and unstructured data, most probably the social media post or full of like a emoji or slang or any typos. There are several content, social media content. There will be posted by the user. Uh, if raw data often contains a error or missing the values or irrelevant information, in the format unstructured format, we cannot labeled again once again. So that's what I want to mentioning the medical data. maybe have the inconsistence or abbreviated. This kind of messy data makes training much very harder. So noisy input can reduce training accuracy, slow convergence, and lead to unreliable predictions. If you take the speech recognition, background noise or overlapping voices degrade model performance. We used to apply the noise and unstructured data. The messy data makes training much very harder. Now coming to the strategies. What are the strategies used to follow to overcome the data? That means sensitive data. The data augmentation techniques, one of the best strategies. Another one is a transfer the learning and pre-trained model and synthetic data generation and active learning and human in the loop. So how do researchers and engineers overcome these challenges? Definitely, we have the several strategies like data augment, transfer learning, synthetic or active learning process. The overview of the different strategies. The augmentation expand the data sets artificially. That means flipping, rotating. That means different type of image. You want to create one image with help of that creating a new data from the existing data. That's what exactly the data augmentation. So the transfer learning also the same. Instead of the training from the scratch, we use the model already trained. That kind of things is called as transfer learning. The synthetic data generation also the we create the artificial data using the simulation. The active learning also the label the human only the most important with the help of the for computing process. The first one, the data augmentation. For example, you take a vision task, rotating, flipping, scaling, or cropping, color jittering, or contract adjustment. So that are things comes into the picture. I'll tell you the simple example. If you take your photo, is one photo, the existing data, like one data is there, one image is there. So I want to rotate the image. uh, the different shape will be created. Again I want to rotate another flipped or some other angle. So again create the one more image. So like that you are used to create the multiple images with the one image. If you have one photo of a cat, for example, you take a photo of a cat, you can flip it or rotate it or change the lighting or lighting effect. Suddenly one picture become many picture. So like that the image augmentation process will come into the picture. So this is very common image recognition task. The second one is the text augmentation. The simple natural language processing method we used to transfer the learning. Instead of training model from scratch, we use reuse the model. That means trained on large data set like a ImageNet. These pre-trained model are fine-tuned for smaller or specific tasks. So random insertion, deletion, or swapping the words. So like that we used to do synonymly replacement or back translation. So all those things we used to do the transfer learning. Another one is a tabular data augmentation and generative approaches come into the active learning process. Synthetic data, uh, we use the create the artificial data. Already I mentioned the pre-trained model. Uh, the adopt a model trained on a large data set to a new related with the limited data. That means pre-trained model, the source of the task, it come into the target model, that means related, then fine tuning the data set. So these were the transferring the learning. I'll tell you the example. A model trained on ImageNet can be adopted and recognized by the medical image with much less data. Now coming to the synthetic data generation, there are several techniques are there in this synthetic data generation. The simulation based generated generative models, and rule-based generation, and data synthesis for privacy. So all those things, the artificial created data that mimic the real world data distribution. It helps when real data is scratch or sensitive or costly to collect. We use these kind of techniques and to uh, overcome the major challenges. Another one is active learning and human in a even in the loop. The machine learning approach, where the model queries human expect annotation to label the most informative and uncertain data samples, improve the efficiency. If it see the diagrammatical representation, so you give the initial model training. That means train the small labeled data set, then it come to the unlabeled data pool, then converted to the query strategy. Model select or uncertain or ambiguous samples. So like that, we used to model refine and expert the label from the queried sample. Finally, human in the expert provide the labels for the queried samples. The major benefit is reduce the labeling cost or combine the uh, human expertise, focus the most useful data, or combine AI efficiency and boost the model accuracy. So these are the major benefits for doing the active learning model. Now coming to the big data infrastructure. Another again, is to come the another part, the major part, the big data infrastructure. Another question come into our mind. So how do we manage the massive data set? So this brings us to the big data infrastructure. Already we know the big data in the cloud, three V's: veracity, velocity, and volume. We already we studied the cloud environment, how to deal with the big data. So now the part distributed computing framework, Hadoop and Spark, cloud-based storage and processing, and GPU and TPU training, and scalable data pipelining. So these are the major big data infrastructure. First, distributed computing framework. So like Hadoop and Spark, it is used to allow the process data across the thousand of computers in a parallel. It's like dividing a big exam among many students. For example, if you take online exam, at a time there are thousands of or lakhs of people are writing the exam in an online mode. So dividing the system, the big exam among many students, so it gets finished very quickly and get the result probably within a few minutes. So like that, we goes to distributed computing environmental. It gives the very much effective and efficient. The second one is the cloud-based storage and processing. So as we all know, Hadoop is an open source framework for especially the distributed storage and processing the large data set. Uses the HDFC, that means HDFS, Hadoop distributed file system, for a scalable storage. With the cloud, uh, we not to carry the hard drives or anywhere. So data is stored in a server that can be accessed anytime, anywhere. Uh, Heavy AI tasks can be also run on a powerful cloud servers instead of the personal laptops. So that's what the beauty of the cloud-based storage and processing. So the comparison between the Hadoop and Spark: disk-based and reliable, slower and batch job, and Spark memory-based and faster, support both batch and streaming method. Normally, the cloud-based, we used to work with the heavy AI task, can also run in the powerful cloud servers instead of the personal machines. Yes, that's what I'm telling. The storage futures: save the files remotely, access anywhere, anytime, easy backup and sharing. And the processing: run heavy task and data analysis and scalable, central cloud, store access, backup, everything. securely access the data, accessibility, scale, everything the come into the picture of the cloud-based storage and processing. The next GPU and TPU's training pipeline. So these are the special processes designed for the deep learning. While the normal CPU might take days to train a model, but GPU not like that. It can be do it in hours. So designed by the Google or even very much faster. The generative pre-trained model that be given as a graphical processing unit and that tensor processing unit. This specialized processor accelerator the training of deep learning models. The scalable pipelining data pipeline ensure the smooth ignition process. That means pre-processing and analysis in a real-time manner. If you put into the data source in AI training, we get into the processing model and pipeline ensure the smooth ignition distributed storage and analytics the machine learning and training model. We should take the case studies. Some of the real world success stories to see the real impact of data intensive learning. Let us took some important case studies, real world success stories that prove the power of data. First, we go to the ImageNet, powering the breakthrough in computer vision. The first ImageNet in the year of 2012 or after that, a deep learning model called as AlexNet trained on the ImageNet data set, which had over a million of labeled image. This breakthrough the improved computer vision accuracy and started the modern AI revolution. The data set, the millions of labeled images and thousands of categories by the model that trained the deep learning and given to the applications, anonymous driving or face recognition or object detection or medical imaging, robotics. So everything. The breakthroughs improve the computer vision accurately and started the modern AI revolution. This is one of the best example. So another one of the best example case study, large language model, shortly called as LLM. In this large language model, it's like a GPT or BRT, generative pre-trained transformer, or the bidirectional encoder refreshment from the transformer. The trained on massive text data have the neural or natural language processing, so powering the chatbots or translator or content generator. So all those things, this model were trained on a huge volume, like a terabyte of text data or books or articles or website. The massive data that can be processed and as a result they can understand and generate a human like language. So this way we have chatbot today, very familiar. Everyone use the chatbot to getting fed, getting some queries or clarifications from any of the applications. Nowadays, all the applications are even a website, or you take any small applications also. There must be a chatbot is there. If you want to any queries or doubts, or immediately they should clarify with the with the help of the history of the data. Already we used to feed the history of data. Based on that, they give the solution for the user queries. So like that, the GPT and BERT, we were trained on a terabyte of text data or books, article, and website. As finally we get the result, they can understand and generate the human-like language. Whatever we asked, they used to reply. So this way, we have chatbots today. The natural conversation may be happen. the model, training, application, and impact. The another important case study is the healthcare. The third one is healthcare. AI is uh, uh, now helping to the medical field, like uh, helping the doctor. For example, if you take the photography of any of the prescription, the 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 ChatGPT immediately or give the uh, report, immediately give the report, whatever, what is the MRI scan, or what is the what is your medical record, or is there. So immediately that helps the doctor to analyzing medical scan. Even if it is the user, they can be helped to find the disease immediately. In some studies, AI has matched or even outperformed radiologist in detecting the certain types of cancer early. Or this does not replace the doctor, but it gives a tool, powerful tool, gives some suggestion or solution to the user. The input data, for example, if you take the medical image or X-ray, MRI scan, CT scan, ultra scan, so immediately put into the AI analysis, that can be give some prediction or analysis or result based on the report. The CNN model are trained on a data set, give the disease detection. It may be tuber or anomaly identification, whatever it is. So immediately that gives the report to the user. That means impact, early detection, or improve the accuracy, or faster workflow for personalized medicine. Another important uh, autonomous driving, sensor fusion, and real-time data. If you take self-driving cars, the input, sensor, camera, radar, GPS, everything come into the picture. The self-driving cars combine data from the cameras, radar, and sensor to make the split the second decision. So like that, the constantly learn from the massive amount of driving data collected from the worldwide wide, finally give the solution. That mean navigation or obstacle avoid or safe driving. So that are things give with the help of the input data, a sensor, camera, radar, and GPS. They integrated the data stream working begin all those things and creating the environment model, and we used to apply the AML algorithm or object detection, or the path planning, everything come into the picture, and finally give the solution to the user. These examples definitely the shows that the deep learning success is not just algorithm. The real secret is we used to give the ingredients of data. That means the data only do all those things. The algorithm or any mathematical process, it requires, but the major food is data. So that's what I'm the the infrastructure may used to give the direction to all those things. Now coming to the future directions, democratization access of the data. Yes, we are handling the next, the future of deep learning and big data is both exciting and one of the challenging. The democratized access to the data is more open. The open data set are being released. The researchers or students or uh, anyone who can worldwide can experiment and innovative. It's not a just a big companies. So everyone, every researcher or students or anyone can experiment and innovate with their ideas. So that's what the future direction. The secondly, privacy or perversing the AI. Techniques like federated learning or allow the artificial intelligence to learn the without data leaving your device, like a Google keyboard or Gboard or learners. You're typing some frequent habit without sending your keystroke through the cloud. So that kind of things in happen in the future. Privacy preserving the AI federated learning model. Another one is a multimodal learning. So is the future AI will not only understand the text or images, but definitely it combine all the text, vision, audio, everything come into together. That means multimedia coming together. And we just imagine AI assistant that listen to you and see what you are pointing at or responding intelligently. That are things the multi-model learning come into the uh, future. Another one is a continuous learning from the streaming data. Instead of the training ones and stopping, AI will continuously learn, just not like a human being. For example, the stock market. If you take a stock market, AI will keep on updating and real time as a new data flow is in. So that the future about the making the AI smarter, very ethical and more inculcative. So that's what I want to mentioning here. Now coming to the overview of my the presentation conclusion, to summarize what we have discussed so far. The deep learning is so powerful, but is only as good as the data we want to feed it. Without data, we cannot do any of the algorithm or any of the mathematical process. Definitely, only as a good data we feed into the deep learning model. The another one is a data matters, not just a quantity. Definitely, it come into the picture of the quality of the data. Quality and diversity is a major part. Handling the scale and diversity and quality is a key component for the data learning, deep learning. Another one is a working with the big data brings the biggest challenges. Cost, one of the biggest challenge, cost and privacy and imbalance and noisy data or unstructured data. So these are the biggest challenge we used to face while processing the uh, data, especially the deep learning massive data. But with the strategies, we used to follow some strategies like augmentation or transfer learning or synthetic data or any of the strategies like active learning, or we can overcome all the challenges. Another one is the big data infrastructure. As we mentioned in the earlier slide, the cloud infrastructure, from the distribution model, especially in the a GPU makes all this possible, the cloud environment. And then case studies like future ImageNet or GPT or healthcare or autonomous driving prove the real world impact. Future replies very smarter, ethical, and scalable data usage. So, looking forward, the future and deep learning is about the smarter, ethical, and then continuous use of data. Then only
Good evening, everyone. If you have any queries, you can ask your queries to the guest. Our guest is waiting for answering your queries.
Participants are asked to raise your questions if you have any doubts.
Okay, I hope everyone cleared or got some points.
Yes, sir.
Okay, thank you.
I kindly request the participants to stay in the line to give vote of thanks to the today's guest.
Thank you
Sir,
so much
thank
for
you
your.
so much, sir. Thank you so much for your valuable presence today, sir. Thank you, one and all. Thank you, sir.
Thank you so much, madam.
Participants, please stay in the line for starting the next session. In chat box, feedback link will be shared